Hello, this is Rob Hirschfeld, and I wanted to pull together a short demo of OpenCrowbar, sort of wrap things together and show you the capabilities and technology that we've been pulling together. This is the system overview screen, and I'm right at the end of the earlier demo about setting up the dev system that we're going to jump into. I've run the Crowbar in a Docker admin node. This actually did a full Crowbar install and then did automatically launch the APIs to install the admin server. This is the system overview page. It sort of shows you everything going on from a functional layout. This is the roles view of the Annealer, where I'm watching this admin node setting up all these roles that are necessary to run the ops infrastructure for a data center, from DNS, NTP, DHCP, provisioner, the Pixie boot server. All those components are getting set up now on this Docker admin node over here. I can actually show you. So this is the Docker node, which is running CentOS right now, and we're letting it converge. This will automatically exit this script when we complete, although I can stop it right now so that the UIs and the APIs are already up. If I Docker and show the processes, you'll see that this is the admin node right here that's come up. I've been running it for about 8 minutes. And as it goes through, it'll complete the process. And there's a lot to show and tell about OpenCrowbar. The number one thing that I really want to focus on with this is sort of the UI and how it works. We'll show some of the CLI also. But it's really with the Annealer, because the Annealer is the magic that makes Crowbar orchestration work in a predictable, reliable way, and is really at the heart of what we think is going to help provide upgradable physical infrastructure based on some of the core tenets, Crowbar like late binding, where we don't make decisions about the infrastructure until you've actually discovered the infrastructure. So RAID and BIOS and networking configuration is done really after you've discovered what the infrastructure is. You've made decisions about how you want your system to look. Then you can make decisions about what roles the system takes on. The view in front of us is the Annealer backlog, and what it's showing is I have one role that's being set up, in this case the provisioner, by our Chef Solo jig. When that completes, it'll continue moving forward, and all these items are blocked. So one of the really important things we did in OpenCrowbar was we took our deployment infrastructure, which had been broken, which had been sort of very monolithic, and a collection of chef roles, and we really wanted to create something that was much more atomic and easy for people to monitor and watch. And so the way that translated out for us was to build this infrastructure where each action is very atomic. So from any one of these, we call them node roles, it's the intersection of a role and a node, I can get very, very specific information. I can see what had to be done first, I can see what is coming next, I can see its state. If there was something broken, that would flag up as an error very quickly, and I can see exactly what the system did in processing that action. So each one of these is very small. They're done by what we call a jig, which is the running action. And jigs are really extensible, CMDB agnostic. So we do a lot with Chef Solo. We have a Puppet jig. We have a script jig, which actually just SSHs in and runs bash. We could run API calls. This is really, it could be done as an out-of-band process. So it really is open for extension. As a matter of fact, we have a list of the jigs. You can see there's quite a few of them in what we're doing. And same thing with roles. So each role is tied to a jig, and you can see that we've built quite a number. We have test jigs. No-op jigs are effectively milestone points that we use to create checkpoints within our deployment. So when a node is discovered, or if a node is managed, or an operating system is installed. We also have a Docker role, which allows us to have Docker come in, and the Docker node actually can provide other roles. So there's some really interesting logic in how we deal with the concept of bringing up a very complex, interdependent, some ways clustered and circular deployment path. And that's been one of the things that's been important for us to bring together. And the annealer and the design of the annealer has been a long time in the making and has been part of our gaining the experience for how physical infrastructure deployments that can do the type of bare metal RAID and BIOS and networking operating system install bring up. And actually Docker containers also, which turn out to be a pretty interesting operational challenge because of what you can and can't do with Docker. So as we watch the systems literally going through and applying each one of these roles, building things up, in some cases we're actually building PXE boot images from ISOs. In our system we cache them, but you can see I've installed Ubuntu and CentOS, and the actual information that we've collected from those repos is a lot. We hide some of that under our in the UI. Our UI function is very focused on exposing capabilities for Crowbar. We haven't reached a generation point yet where we're really trying to create use case focused UI overwrap. And you'll watch me walk through the UI and you'll see that it exposes a lot of capability, but it's one of those places where we obviously know there's a lot of improvement to come. So let me walk you through what we've done. I think we've just about completed our deployment here. We have. System has reached a stable point. And at this point, what I want to do is take the next step. So for this, I've built this dev system. I showed this in another video, so I'm not going to try and repeat it. But I'm going to go ahead and boot 2 worker nodes into the infrastructure. So here's one node. I've connected my networks together, so my Docker admin is actually connected to the same virtual bridge as my management interface on this node. And I'm going to boot a second one. And these are literally being PXE booted from the Crowbar PXE infrastructure. So Crowbar set up a DHCP server. That DHCP server is directed to PXE boot these nodes by default. And then as it PXE boots them, it'll bring up our discovery image. Our discovery image will talk to the Crowbar APIs and set up, register the node and put it into a default configuration. What's really important for us, especially with capabilities like Docker, is that you don't have to use our discovery image to add nodes into Crowbar. The discovery image does that by calling the APIs, but you could preload images into Crowbar using the APIs. When we build containers, we actually use the APIs to create the container as a Docker node, and then spawn, allow the Crowbar itself to do the Docker run to build the containers. So we've really worked hard to not be entirely limited to discovery images using PXE. We've really tried to keep the Crowbar infrastructure very flexible because that allows us to do things like take advantage of Dell's iDRAC discovery process, where we can actually discover nodes that haven't even been powered on yet. So there's some really cool capabilities that we can do by having an out-of-band management communication process and an out-of-band discovery process. These nodes are going to come up. What I want to do is I'm going to build a second deployment. So deployments for us are scoping boundaries. So I can add a deployment here. Sorry, I just created one called default. Let me create another deployment called demo. And the idea with deployments is, we found that this is a very important concept for people, is that we can have multiple deployments. These are children of system. System is our discovery deployment. All nodes will come into that initially. But the idea here is that we could actually have a test and a dev and a production deployment that had similar things, duplicate cert databases or message buses or things like that, or networks that were just used for that one deployment scope. And this is a really important thing. Using something like Chef Search, like we used to do, made it very hard for us to create multiple configurations, multiple deployments within the same system architecture. And we really made it a point in OpenCrowbar to not repeat that mistake. So what we can do here, my system's a little draggy as I'm booting up all these nodes and putting some stress on it. Here's my networks. So I have my admin network is my default, and I have certain ranges. I'm going to configure a new network. For the purpose of the demo, I'll call it Ceph, because I actually have some Ceph roles I can put in. I'm going to go ahead and put it in the demo deployment. That means it's scoped to that capability. I'm just on VM, so I don't have a VLAN. I could specify that. OpenCrowbar uses IPv6 as its default, and IPv4 effectively as an overlay. And so that's been really important for us to be able to enable a lot of interesting capabilities and a lot of network resilience by using IPv6 as our primary network. And then, of course, IPv4 allows us to work with a lot of legacy capabilities. I can set up bridges and teams, and once I add this network, I am good to go on this, and I can start using it. I actually don't have a 10 gig network, I have a 1 gig network, so I'm going to update that. And the other thing I'm going to do is add a range. I'm just going to call this my public range for here. So what I've done here is I've set up this network, so I now have a public network on this range, and that will let me actually provision this extra network. Even if I don't plan to use it, I'll show in this demo how we provision it. The nodes have come up, so I can go back to my system deployment, and what you'll see is these are the two nodes that I just brought up, and this is the roles that I'm adding into the system. And Crowbar has brought in new roles. So we have a logging server on the admin node and logging clients on the other nodes, NTP clients. Basically, as we bring in new things and new capacities, new roles, as we're working towards this node discovered, which is one of our milestone roles, it brings in all these other roles and capabilities. So let's let this thing run. So I let this system run all the way through to getting all the components provisioned. That means my Annealer now has nothing going, and now we can jump right into actually doing some interesting work and letting this continue forward. So I'm going to go into my demo deployment, and I'm going to do two things. First is I'm going to put in the Crowbar, the OS install role. In this case, this is one of our milestone roles. The only thing we show in this list are milestone roles, or no-op roles, as we call them internally. And then I'm going to need to add some roles. So here's a deployment. I now have a role that I want to achieve, a milestone, and some nodes I need to add to it. So let's go ahead and put these into this deployment. Great. So now when I come back to this deployment, I now have nodes, I have a role, and if I add that role to this node, so I'm literally assigning, I want this node to reach this milestone. Crowbar says, hey, wait a second, if you want this milestone, I also need the installed OS. I'll give you an example of another one, the Ceph config. If I add that role here, I can choose, I can say, well, I just want that config on this one. Notice it doesn't add it for my others, but it brings in the network. So my Ceph config says, hey, you need to have a network. This is the network that I configured earlier, and it's going to go in and set it up on the system. So the wrench indicates that I'm in a proposed state, so I can go and change things. So for this node, let's go in and he's on CentOS. Let's go ahead and let him, or her, I don't know which sex this node is, or if it matters to the node, it be an Ubuntu node. And this one we're going to leave as the default for CentOS. And you'll notice I can set it by the node. I also have a deployment level value, and I could also change that if I wanted to. So I can set things either at the deployment, system, or individual node roles. So now I've got a deployment that looks like it's in pretty good shape. It says I'm going to install the OS for this one, and for this node it's going to go a little bit further and start running to our Ceph config. And the Ceph config right now is only going to set up the network on the second NIC. We remember when I set that network up. So now hasn't done anything yet. The Annealer just has some proposed new state. I go ahead and commit that. That takes this these node roles as proposal and sends it to be configured by the Annealer. And at this point the system says, all right, I need to do some provisioning. Most of the action is going to happen over here in the on the system deployment, because this is where it's actually got to do the provisioning. And the first thing it's figured out that it has to do is change the DHCP boot records. And that makes perfect sense. I'm about to tell these nodes over here to reboot, which is exactly what they're doing right now. It's doing a shutdown and reboot. And so in this case, it's saying, aha, instead of running our discovery image, which is called Sledgehammer, I've now set that to be a CentOS 6.5. If I jump back to the other node, this one, you'll notice that this one has my Ubuntu. So each one, depending on the configuration, has been given a different set of boot media. The system configures those nodes off until they report back in. So even though they're busy doing an OS install, they're not available for Crowbar and they're considered off. And so if I look now at my Annealer, I can look at my background work and see, all right, I'm waiting until the nodes come back on. So these are in a to-do state, basically on hold, until they complete the OS install. And you can see in the background over here, I have 2 OS installs running very happily, pulling down a whole bunch of resources. If you build something like this, a gig of RAM is a minimum for an OS install. We recommend 4 gigs for the Crowbar dev admin server. If you're going to actually run containers, which I'll show you how to do, more RAM is better, because containers do take some incremental RAM as you spin them up. If you do like some of our devs like to do, which is spin up 30 or more containers to test your system out, more RAM, better. We have some 32 gig RAM systems. That's what I would advise if you're going to do some serious parallel system deployment using containers. Of course, that's a lot lighter than if you were to build 31 gig VMs on your system. So basically right now we're back in a wait state as we build up the capacity. Time to show you a couple things. So I showed you networks. We actually have a network node map that shows you IP addresses that have been assigned to nodes. We haven't gotten all the way there yet, so we don't have that much in here. Bus interfaces is really important. When we set up these 1G1, 1G0 NICs, the enumeration for each system is controlled from here, because what we found is that as you add NICs into systems, the enumeration can vary, and so we had to provide a way for you to create custom enumerations. And there's actually a regex pattern that you can use to match systems generally or specifically. I showed you system overview, I showed you roles. Bar clamps, if you're used to Crowbar, we still have the concept of bar clamps. It helps sort of to take these big concepts and break them into smaller. So we still have sort of bar clamps as concepts above roles, but we don't highlight them to the same extent that we used to. We really cut the Crowbar repos. There you go, Crowbar. We really cut the number of repos way down. So if you look at the OpenCrowbar repo as opposed to the old Crowbar repo, you'll see it's pretty logical. We've got a Ceph, OpenStack, Core, hardware, Hadoop, a much smaller number of targets for people to develop against. And Core contains all of the core pieces for Crowbar. And we've been integrating documentation into that repository. So if you've looked at Crowbar before and been confused about all the wikis and things like that, we really have worked hard to try and put all the documentation in the code base in GitHub. It's easy enough to edit through the GitHub UIs and much faster. And I'll highlight our quick start documentation with Docker that lets you sort of bring up the system really quickly. So we've got some systems that are busy booting. I'm going to pause, not have you watch as the system goes through its deployment, because until the node's actually discovered, fully booted through this, there's not much to watch except OS is being laid down. It's very different in Docker. Docker's a little bit quicker. I'll show you that when I come back from the break. So I'm checking back in on our install after a couple minutes, and what you'll see is that this system here has completed the install, and the behind the scenes script is checked into Crowbar. It said, hey, the power's on. So if I look at the system, you'll see it's on. And now you can actually see the work that needs to get done. And one of the things I really enjoy watching with the way the Annealer works and how atomic we are in our actions is that I can see exactly the work that needs to get done in the order it's going to be performed by Crowbar. So I can see it's building the admin network right now. It's installing the DNS logging and TP clients. It's setting up the repos so it can do, in this case, apt-get. It's setting up the deployer client, and then it achieves the Crowbar managed node state, and then it's going to go ahead and complete the provisioner OS install and the Crowbar installed node. At that point, it's going to say, hey, I am a complete node. And since we don't have any agent, at that point we could actually detach Crowbar and just use this system as a system. We could also leave Crowbar around, and if we ever had to make changes, Crowbar would SSH back into the box and do whatever configuration we needed. You'll see I've also set up, here's my IPv6 address, here is my IPv4 address out of the pool, and actually I'll show you where that gets set. So in the admin network, these are the ranges that I set. So I have my admin nodes get pulled out of this range, DHCP, so we have a 60 node range for DHCP addresses. It actually is used by the DHCP server when it sets up DHCP. And so if you change this, the DHCP server will be changed. And this is the host network, so these are the statically allocated node ranges for the host, and you'll see we actually have this as a 22 range. So with the Docker nodes coming in and setting up 100 nodes, we actually needed to blow this out a little bit more. And then in the Ceph network, I did a different range. So this actually gives me, if you're used to Crowbar 1, we used to do this. This was called in the network JSON file. In this case, we're much more adjustable, meaning that you can make these changes and update it. You don't have to do it all post before you even do the install. So a major improvement in how Crowbar operates in that sense. So Ubuntu's still installing over here. I'm losing patience in that. I'm going to go ahead and demo our Docker node bring up, which is going to put some more stress on the machine, but I think we should be able to handle that. So you'll see I'm still in my Docker infrastructure. I've only put you through 22 minutes. But 54 minutes of, or 40-something minutes of elapsed time has gone on. And what I'm going to do is, we have a tool for Docker slave nodes. What this script will do is it actually creates nodes using the Crowbar API, and then creates a screen session for each one of those, actually a tmux session, which is like screen, but doesn't have a 40 session limit like screen. I'm going to just go ahead and create 6 slaves here and kick that off, and you'll see it's actually bringing up, these are different screens. It's hitting the API to create that Docker container, and then that tells Crowbar to go run Docker containers. So I'm going to let it kick through the 6 that I asked for. We're at 5. Here's 6. Returns control to me. So now I'm back to the system, and if I do a Docker PS, you'll see Crowbar is actually now spinning up these Docker containers, and you'll see them in the UI. So one of the things that's really nice about Docker is, unlike the process that I follow to bring up a new admin node, the Docker containers are boot very quickly and have available OSs really quickly. So where it's taken me 40 minutes to provision up some VMs through Crowbar that I can actually use for deployments, my Docker nodes will be ready in just a couple of minutes, or actually less than a minute, as it works through the annealing process. Crowbar can operate, we have 10 workers in the annealer, so it can do 10 simultaneous tasks per node. So we single thread through a node, and we parallelize as much as possible. If I look at the annealer here, my laptop's getting a little warm as I'm putting some stress on it. you'll see that we're working a whole bunch of actions in parallel in the infrastructure, and then we're tracking a whole bunch of work to be done in the background. And I can go into an individual node. Oh good, I got an error, so I can show you what that looks like to correct. And I can see my attributes aren't set in Docker. Can't do the same type of inventory. I can actually see what's in process. So I can see, my admin network failed to get set up, and then these items are blocked. And then what's happening right now is my Docker containers fail simply because my system is too busy. And so what I really like to see here is that I had a failure in my atomic operations, and I actually can see exactly what the node operations were. I can get very detailed diagnostics, and the way the annealer works, that one thing fails and it stops downstream work. So it gives me a chance to fix and correct. Other things will flow around it if this error isn't blocking. So if this node role isn't required by other things. And what I can do, I'm not going to retry just yet. I'm going to let things settle down a little bit. My system's just a little bit bogged down, so retrying this error is not going to help me recover any faster. Actually, I'll do it just to see what happens. I can take my error, correct the issue. In this case, pixie dust on my machine to give it more CPU and RAM. Hit retry. That puts it back into the to-do state. I need to fix that. That's not actually a bug, it's just a routing problem. And it's going to go back and try again. So here's Docker 2, it's back in this role. You can see all my other containers have advanced beyond that, and they're moving through the actual deployment, and they'll get to a usable state very quickly. If I go into my bulk editor, I can start moving those into my deployment, so I can put them in different deployments depending on what I want it to do. The reason why this is really important capability for us is that it lets us do multi-node scale deployments without needing a lot of VMs or a lot of physical infrastructure. So I can build real op scripting that behaves as if it's a scaled out system, do HA build outs, things like that. And from a developer's perspective, and even a QA perspective, I can go through those cycles much, much faster with a lot less resources. This has always been a hurdle for us in any of our testing, whether it's Hadoop or OpenStack, is the cycle time it takes to do a deployment test. And reducing that means more time testing, checking, developing, less time watching OSs get built and installed. So a significant advantage here. If I tmux into my environment, I can actually see I'm not tmuxing correctly. Oh, sorry, tmux crowbar Docker. Familiar enough with tmux. In this case, I'm actually in the right place, not using tmux correctly. So I can scroll around in tmux, Control B, next, N, Control B, previous, moves me back and forth to different containers. If I wanted to, instead of going through the containers like this, I could from here, I can actually go into my system. So let's say I wanted a Docker container. Docker 1, green check means it's all finished. I could use its DNS name, let's do that. Or I could use its IP address or its v6 address. But from this container, first I can do the crowbar CLI. I can spell crowbar. Then I can take action on crowbar using our CLI from the container, or I could SSH as root So I just wanted to check back in. I've got all my systems up and going, and so basically I've now got a system that I can continue doing deployments and playing with, and otherwise enjoy as an ops environment for deploying things like Ceph, Hadoop, or OpenStack. And it's worth noting, we're still working on bringing those workloads and other workloads into the Crowbar environment. The point of these demos is to show an environment that deploys the base core for us to work on top of. That's really our key milestone for right now. So hope you've enjoyed this demo and gotten something useful. Please join us on the Crowbar mailing list, bit.ly crowbar-list, or you can also join us on Freenode Crowbar as our IRC. Thank you.